wanna keep it a mess. You know my intuition. I got bars and it, but never in a prison. Too far gone, never gonna sit and listen. This is what the mix, mixing the best. You get it up. What you're seeing is a piece of the flesh. I'm better up. I don't need to try to speak for the rest. Always keep it a crap. They wanna keep it a mess. You know, this is what you get when you're sitting as a vet. But everybody knows you're a
They love me. They love me.
We're back, ladies and gentlemen. This is Techsplanation. I'm your host, Nick Smith, here as always. Actually, this week, I'm in the Folsom office. I'm on the sunny west coast of California, hanging out with the team, shooting this one live in studio. Really excited for today. It's going to be a fun show, ladies and gentlemen. Now, we're going to get right into it because we've got some, just deep nerdery that's going to happen today. So,
Yes,
no
we do.
stories, no subtext, no fun, right into the nitty-gritty. But in order to do that, I need to introduce who's with me in studio today. Everybody give a warm shout out to Jordan Winkelman from Quantum. You're here.
I am
In studio this time.
in studio.
I love it. Good times.
It is.
All right, first off, if you're watching on Vimeo, make sure you log in so that you can leave comments, ask questions, chat with us. If you're watching on LinkedIn, thank you. And do the same. Make sure you ask questions, leave comments, or just give us the thumbs up when we say something stupid. And if you want to make a drinking game out of this, we highly recommend bourbon.
I like scotch.
Okay, scotch. Scotch is the drinking game of the day. Vodka is fine too. Honestly, anything you have in a bottle is okay by us.
Don't drink.
Hey, doesn't mean I can't push people to enjoy the show in whatever variety they want. Okay. So we're going to talk a lot about cloud today, but not the cloud that I think everybody is kind of thinking of, because Quantum's doing some interesting things with cloud right now, and I want to kind of dive into those and discuss that. Oh, it looks like we've got one fan raising their fingers for vodka or tequila. That's good.
There we go.
All right. So, Jordan, go ahead and actually, we're going to have to separate. So producer Jordan from contestant Jordan. King Friday, if you would throw up the first slide so the audience kind of knows what we're talking about today. So we're talking about cold storage. And cold storage is sort of that you called it out early. You called it the thing no one wants to use.
I call it the restore point of last resort, typically. But that's the stuff in the cloud as opposed to what you might keep on premise.
But why is that? Why is that the last resort?
Because you don't exactly know what the cost of retrieval will be. If you're in a super fast hurry, you're going to pay for your expedited retrieves, and there might be a significant cost with just bringing the data back online. And then depending on what kind of connectivity you have to the public cloud, you may be paying additional egress fees. And those can be far more than the monthly bill for the overall amount of storage you have.
So let's step back for a second and help the audience understand, because we kind of, I think for maybe somebody who doesn't live in this every day, they think of cloud storage as just, look, it's just a big bucket in the sky I throw data into, right? And in the media entertainment world, we use a lot of cloud storage because we generate a lot of really large files.
That we do.
Right? But not all cloud is the same. There is active cloud, meaning it's on a spinning disk in somebody else's data center. And then there is LTO cloud, which is really that iceberg frozen storage of, like cheapness.
Anything called deep or cold storage in the public cloud, that's almost guaranteed to be LTO tape.
Why is that?
Because the cost metrics of storing data that's cold in the sense that it hasn't been accessed in a significant amount of time and may never be accessed again. You're possibly holding on to it for compliance or, whatever reason that you have to hold on to that data. But if you're not accessing it, you want to put it on the lowest cost tier of storage where it's cold because you don't need power, you don't need cooling for that storage. The total consumption of a tape library, a full rack of 20 tapes might be 1,000 watts versus a single server being close to 1,000 watts and having, maybe 100 terabytes at best.
I mean, if we put the Wayback Machine on, this is the equivalent of a VHS store, right? I mean, we go to the video store, the Blockbuster of 1991, and we find VHS tapes. And effectively, that is the equivalent of an LTO tape, right? It's, with more capacity.
It's iron on plastic, yes. Yeah. There's 18 terabytes native on today's LTO media. And while people consider LTO slow or tape slow, it's actually 400 megabytes per second per drive. So when you add up a significant number of drives, you can get crazy performance, but you also have to have your target storage where you're restoring to has to be that fast. Otherwise, no
place to put it.
Exactly.
Yeah. And then there's also the random access issue, right? Now, in the cloud, I can access any file at any time because it's typically on a disk that you can move the playhead quickly, the reader across that disk platter. But with LTO, because it's a linear tape, I have to spool it up. I've got to fast forward and rewind. That's why we always say, please be kind and rewind your LTOs before you return them, right? You got to spin that tape to the location where your specific data you're requesting is. And so does that affects performance effectively?
I'd say it affects latency. So time to first byte, there's a perception issue, and that's why people think that tape is slow. I need to go and have a robot grab a tape from a slot, move that arm, put it into a drive. If a drive isn't available, yes, it's going to take a while to get access to that data. But once the data starts flowing, it's extremely fast, and it can be faster than pulling it back from a RAID in many cases. If it's local in your own facility, it's going to be way faster than almost any internet connection that somebody can afford. And so you can have extreme performance with an on-premise tape archive, whether it's just writing a file to a tape or even erasure-coded tape.
And I think that's, part of the understanding is this is why it's so cheap. Right. This is it's not active. It's low power. It's low heat and cooling. It's effectively a tape sitting on a shelf until somebody requests it. And then is when the money comes, right? That's when it gets pricey.
So here's the thing about the public cloud and cold storage. There are no tapes that get taken out of a library. They just buy more libraries. There's thousands and thousands and thousands of these full rack or kind of shipping container wide tape libraries. So while it's not online on a disk, there's no human being who has to go and load a tape from a vault or anything like that. And so that's when tape becomes the most advantageous of a medium, when there's not a person who has to go and physically move something from here to there. Let the robot do it. The robot's going to do a better job more safely handling that media, because the number one challenge to tape media is us when we drop it, or the figurative or even literal falling off the back of the truck from whatever vendor comes and picks up your tape media.
Now, we've got a couple slides to help the audience with this a little bit. So, Jordan, let's punch through those King Friday, I should say, those first couple slides. Here, Jordan, I'll swing this over so you can see. We're kind of, and we answered the first one, which what the heck is cold storage, right? Because we hear this concept of storage, cloud storage, but we don't kind of isolate what we mean by cold storage. But if we move past that, And as we mentioned already, you've got sort of two flavors of cloud storage, cloud on LTO or cloud on spinning disk. Are we missing anything in the cloud there in terms of just the cloud conversation?
I mean, if you have virtual machines that are on or not, I guess they're bare metal systems where they have dedicated NVMe, that's not going to be presented as like an S3 storage typally, unless you're...
That's sort of dedicated block storage to that.
Dedicated block storage to that. If it's going to be S3, it's probably on disk, whether it's fully spinning disk or whether it spins down as appropriate. And then you'll have LTO media typically.
Okay, so LTO. Let's talk about LTO, because here's an interesting one. When the pandemic hit, they who shall not be named, we sort of saw like everybody just rush to the cloud. And I thought for a minute tape sales were dead. I thought tape was dead. Like LTO's done. Nobody will ever put a library on-prem again. It's all going to the cloud. Not the case?
I sell more tape now than we ever have.
Crazy, right?
Yeah, well, the reality is we're the number one player in hyperscale tape. So Quantum, take your pick, whichever public cloud provider globally, there's a good chance that we're their cold storage technology of choice. So whether you buy a tape library for batch backup on-prem or if you're using it as an archive on-premise, we're happy because in a lot of cases when the data goes to the cloud, it's still going into our LTO libraries.
So let's talk about tape for a second. And if you're unclear on what LTO is, Jordan's got a slide to just kind of break it down. So first one is really just LTO drive itself, right? It starts at its root with a drive, which is basically a device to accept the LTO tape and bring that data in. So right now, compressed capacity is 30 terabytes. Uncompressed is 18. So it's a lot of data. So I think our specs are a little wrong on this one, Jordan, but we'll come back to it. I missed that part. But when would anybody ever use compressed for their LTO tape?
Not for media and entertainment. That's going to be more your traditional database type batch backup workloads, not
because
archive.
I think you mentioned compressed to anybody in M&E and they freak out, right? It's like
most of our data is compressed to a degree already. You will get compression on uncompressed data, so frame-based workflows. There will be a lot of commonality, so you do see data reduction there. But on the other end of the spectrum, most of our data is already compressed.
We've done it elsewhere. That's true. I mean, compression means you have to throw something away. Nobody ever wants to throw anything away in the M&E business. It's like, that's bad news.
Here's a funny thing about compressed files. If you compress them again, they get bigger.
Ooh. That's very meta. Let's chew on that for a second, audience. It gets bigger when you compress it. Okay. So you've got this tape, and the goal of the tape is it can last a long time, right?
Up to 30 years.
30-year shelf life, totally.
Yeah.
Now, a tape by itself is great. You and I were spooling one up downstairs a minute ago and listening to the whir of the tape. But by itself, that means manually a human's got to load it, which is why we move into the libraries, right? So Jordan's got King Friday has a library up on screen for the audience. And now this is the small, what's the smallest one you guys?
The super loader?
Yeah, there's a little super loader. Exactly. I think I can see it there. It's in there. So now we get to a point where we can have multiple tapes preloaded, ready to go. So that behind the scenes, all we're doing is just chucking data at it all day.
You can load tapes remotely, all from a web user interface. The backup application does all the workload, so you don't have to go and swap the tape when it fills up. Or, the only time you might go into the system is to grab your second copy so that you can take it offline and send it offsite, hopefully, so that if there's a disaster in your local facility, you still have the ability to recover that data.
And that's a really interesting piece of the story right there. And I think, people don't always think about okay, even though it's on tape, you still could burn your building down. You still could have a flood that actually happened to a client of ours.
Happened to a company I used to work at.
Yeah. So you make a copy, you send it somewhere else. Jordan, remember that. We got to make copies. Okay. So we've got now this small library. Let's jump to the next, which is we get to the bigger libraries. We get to these just vaults where, multiple tapes are inside. So why does somebody choose LTO? I mean, what are the big catalysts to push somebody that direction?
Well, it's low cost. The media is the most expensive component, but terabytes of data are going to be in the single to low double digits for supporting a terabyte for a decade. Whereas in a public cloud environment, you're paying $1 per terabyte per month on the lowest cost tiers of storage. Since you don't need as much power or cooling in your data center, you buy less HVAC system to support your data center. And, as a result of that, keeps your electricity costs lower. And so all of those things add up to pretty dramatic savings. And if you don't need the high bandwidth internet connection to the cloud that can upload really fast, you save a lot of money there too.
I mean, so your total cost of ownership starts dropping even before you restore a file at that point.
Correct.
So I guess the pivot here, and I don't know if the audience caught this, I just switched on you folks. We talked about LTO living in the cloud. The whole point of this is you don't have to have the cloud. LTO can actually live on-prem, which has always been its place. It's just in the last few years we decided to make it somebody else's problem, somebody else's library.
I'm actually going to turn it around on you and say, you may not want the second copy on tape. You may want the second copy in a cloud, because if you use the cold storage in the cloud for the appropriate thing, it's what I call the restore point of last resort. Mm-hmm. And that's because it's the unpredictable costs of retrieving data. Accidental retrieves can be very, very expensive. But if you're doing your high bandwidth retrieve from a local tape copy, it's going to be way faster than the internet's going to be. And it's not going to cost you anything outside of the media and the software that drives the library.
Not a bad way to go.
Mm-hmm.
All right, so let's stop with LTO for a second, and let's talk about cloud. Mm-hmm. Not the LTO cloud, but the
disk cloud.
The disk cloud,
mm-hmm.
right? And what that looks like. So, what is object storage? For the masses out there who don't quite understand how cloud is architected, let's just break it down for them. What's object storage?
So object storage is a big empty space that's very flat, that has no file names typically, that is just a bunch of objects. Those objects are going to be erasure coded. RAID is like an erasure code. You're protecting data, but you have full drives of parity data. If a drive fails, you're going to have this very significant workload on the rest of the drives in that pool. And you know what happens sometimes? A second old drive might fail during that
process.
Goes
at the same time because It's suddenly getting worked harder.
Now all of a sudden you're exposed to the potential of data loss. With object storage, you can have a much larger, more efficient erasure code that has object-based parity, where you might have objects spread across different drives, across different nodes, across different facilities, so that you have greater durability of your data. For example, our ActiveScale platform takes a single file and it breaks it up into 20 shards of an object. And it's going to pick different drives and different nodes and different racks and different sites potentially to be able to spread that out so that if you do fail a drive or do fail a node, it doesn't have an impact on every single drive in that set.
And when you say shards, we're talking about taking the file and busting it into small pieces.
Correct. So think a gigabyte file, cut that into 50 or 20, smaller chunks of equal size. And there's some overhead in there to protect the data. But in what we call a 20/4 spread policy, I can lose 4 drives before I'm even exposed to the potential of data loss.
But not performance, because every drive is independent.
All the drives are independent, and when we actually access the data, we actually just access the first shards that give us the required amount of data to rebuild the object, which we have to do anyways. So in a 20/4, we're going to ignore the last 4 objects that come back from the disks. We just don't need them at that point. We are already recreating the data.
So this software, this technology, this object store, this is what all disk-based cloud is based on.
All cloud is based on object store.
Whether you're using Amazon or Microsoft or Google or whatever, anybody who raises their hand and says, I'm a cloud, effectively, this is what they're
doing. Yeah, there's some older versions that were like 3 copies on RAIDs, and you would have very poor efficiency. But Object Store has extremely high efficiency from a storage perspective, because you get a better erasure code, the data is more durable, and as you grow, the systems continue to get more efficient.
Okay, now you mentioned ActiveScale.
Mm-hmm.
ActiveScale is not a cloud. It's like you don't go to Amazon and say, I'll take ActiveScale, please.
Well, it's a private cloud.
It's private cloud.
I
put it wherever I want it.
You put it on premises in your facilities, or maybe at a colo facility. Or if you've got multiple facilities, you can spread an object store across those sites, and you can equally distribute the data across those sites.
Now, if I'm equally distributed, any file at any location?
Every file on every location.
So no matter where. So if I've got a stadium and a main office, I can dump a file at the stadium, and the main office gets it as soon as it's uploaded, or as soon as it's moved between the...
So object store is only as fast as its slowest link. So you're going to want to have a reasonably high performance network when it comes to a multiple geo system. But if you've got a 10 gigabit link, you'll be able to download files from the object store wherever at over a gigabyte per second.
I remember a time in my life when the concept of somebody having a 10 gig link was like foreign.
I have customers with 100 gig links
That would
these
be
days,
so
or
amazing.
multiple.
Could you imagine having that at your house?
No.
Yeah, no, I wouldn't know what to do with it. I'd be
No.
like, can I Netflix any faster here, people?
No.
Unless I watch it in like quad speed or something. Yeah.
When 16K comes out, you might want more bandwidth. But
No, that is true. That is true. I
it's-
could see my Call of Duty upgrades going a little faster.
it's
but-
hard enough to get good 4K content
Yeah,
today. though.
agreed. It's almost like if there was a strike or something, what would we do?
Yeah.
But effectively, so now you've got this ability to be your own cloud provider.
Mm-hmm.
And I mean, right out of the gate, the benefits to that are faster access and lower cost, I would assume, right?
Mm-hmm. Yes.
Because I'm accessing something that's in my building versus in somebody else's building.
You also eventually pay it off.
See, that's a kick with cloud, right? I mean, if I go to anybody's cloud, I'm always going to pay. And not to say there's not a reason for it. You mentioned it.
There are good reasons
right?
for it, yeah.
I should have another copy somewhere else. Choose a cloud provider that gives you the cost you want and put that file there as your redundancy.
Well, one of the things that I didn't mention about whether it's public cloud or private on-premise cloud is these things are designed for failure. So you're going to continuously have failures, going to bring in new hardware. That hardware is going to redistribute the objects and get back to full parity and full safety. So there is a continuous process of refreshing the hardware, and that's where it becomes something that has that continuous ongoing cost. Thing about cloud that I think a lot of people thought was, oh, well, once I move the data to the cloud, I might not need as many people to manage the infrastructure. Lo and behold, you still have to have experts who now need new skills who are writing the data to the cloud and managing those cloud workflows. Just because you moved it to the cloud doesn't mean you don't need the people to manage it.
Yeah. Well, people are necessary. AI hasn't replaced data movement yet. That's what I'm hearing. So we talk, and I want to make sure we hit some of the salient points. So Jordan, King Friday, you got a slide, the object of your perfection, affection on this one. And I think this slide is, perfection, affection. So object storage involves containerization, right? So we're putting this data into, and explain containerization in this place.
It's not so much containerization. You have lots of little drives, and you take these objects and you write them to individual drives across all of these components. So you have lots and lots and lots of these different locations where you can store data. And because you've made it so simple that it's designed for failure, as soon as it fails, it's just going to fix itself. Similar to containers with Kubernetes, where you have orchestration going on, you might use containers and orchestration to actually stand up a bucket in some cases, like in the public cloud. We have more to talk about that on some of our other products, like our new Myriad file system that we just released.
Well, I think that's for another show. Hold on, let's not.
I got to put the teaser in there.
Put the teaser in there.
Got to get the teaser.
But metadata. Let's talk about metadata for a second, because I think we sometimes people think of metadata as the description that we manually input in maybe a MAM or PAM, a DAM, something along that lines. But metadata exists outside of that. Quantum's always been heavy into metadata. Right, but it's metadata about describing where the file is and what the file is, right, and so that the software layer managing the storage knows where to get it. So where does metadata fall into object storage, and how important is it?
So metadata becomes more important in object storage because there's no such concept as a file or a folder path, and so you have to attach metadata in a sidecar to the object that can help you put that file back together when it comes back on premise. Every different object store or public cloud is going to provide a different object ID based on its technology. And if you move it from one place to another, it's going to get a new object ID. So if you have that metadata built into that object, doesn't matter where it lives, you can now understand what that file name should be. And you can also put other extensible metadata in there that isn't just metadata about where a file lives and what version it is and so on and so forth.
Yeah. It's almost as if Humpty Dumpty had better metadata. They could have put them back together again.
Absolutely.
Jordan, that should have been a slide. This should have been a slide. I'm sorry.
I like that.
I missed that.
I like that. I'm going to start using that.
No, that's fair.
I'm going to steal
is
that.
Completely fair. Okay, so we've got this really interesting story developing. One, cloud is good, but on-prem cloud could be better or should be better, like more flexible, affordable.
You get the same capabilities. It's on-premise. It's higher performance because it's local. You can get the geo protections so that you get the same kind of nature of your cloud being protected across multiple cloud locations. And because it's geo spread in those environments, the data efficiency is incredible. It's as low as 1.5, 1.6 to 1, even if you've got the equivalent of like 3 copies of data. And it's more durable than actually truly having 3 copies of data, which is pretty amazing when you think of it.
That's the impressive part, because you don't have a lot of control over what you put into the cloud. You're just sort of relying on the cloud vendor to make all the right choices for you. But this puts all the control back in your hands to say, how do I want my data dealt with?
Well, here's the crazy thing. When you're dealing with our object store and you have enough media, you might get as much as 19 nines of durability. And that probably doesn't mean a lot to a whole lot of people, but durability, each 9 of durability is whether it's 1 year or 10 years or 1,000,000 years or 1,000,000,000 years, 19 nines of durability, it's basically impossible to lose data. Most public clouds actually only provide 11 nines of durability. They're not guaranteeing that your data is safe. They're hoping that your data is safe. And if you look at other different tiers of public cloud storage, some are as low as 7 or 9 nines of durability. You're being required to have multiple copies of your data in the cloud because of the nature of how they're protecting it in different types of storage.
Which means you're paying more because you're using more.
And more copies, and you may have replicated copies to other sides of the country. You still have to have solid data management practices. Just putting it into the cloud and relying on them doesn't mean when you have a failure in one site that the other sites aren't going to pick up. They may not.
So Friday, if you would pull up the active scale slide, I want to talk about active scale for a second. And so this is sort of the current active scale. The audience is looking at we call the X200.
Yep.
14.6 petabytes per rack.
And now we've got upcoming 20 and 22 terabyte hard drives. So with the current 18s, it's pretty considerable amount of additional capacity in a smaller footprint now too. 270
billion object count, which would go up, I would assume.
Every time you add another set of chassis, you get an additional 10 billion objects worth of metadata. Unlimited scale.
And then it's powered by StoreNext and S3. So
there's no StoreNext.
No StoreNext.
No StoreNext. This is a completely different technology.
So when somebody's saying, "Hey, I use Amazon because of the S3 API. That's how all my data movers, my software, everybody that interacts with my storage is S3." Glacier
is a subset of S3. It's now just a different API call inside S3.
But ActiveScale speaks
We
S3.
also speak Glacier 2 now.
Oh.
So we do provide an all-disk platform for higher performance, immediately accessible online, sub-millisecond latencies. But being the quantum LTO tape people, we actually merged LTO tape into the object store.
Okay, so that's let's sit on that for a second. Merged LTO tape into the object store. I mean, so how I know object store is you've got these disks. Each disk is independent. I take data and I shoot it through a buckshot of a shotgun, and I spread that data on disk. How do you do that with LTO?
We're doing it twice with LTO. So the first time is on the tape drive, on the individual tape itself. With Object Store, you take a file, you write it into a disk. It might be a gigabyte file, it might be a 50 megabyte file. It doesn't really matter. It's going to get stored in its native format. But when you're working with tape, you really want all of the small files and even some of the big files to get packaged up into a larger object. So maybe let's stick 1 million objects into a terabyte chunk on a tape. Well, that allows me to read the full tape at line rate, so about 400 megabytes per second. Extremely fast, regardless of how small the files are. So in a traditional tape workload, you're going to start and stop the tape head every time you read a file. That's not very nice to the tapes. Too much
stretches
of that, you can damage the tape over time. So with Object Store, we are taking into account the best manners in which you're interacting with the tape. You're getting the highest performance. You're not starting and stopping it constantly. And as a result, there's less wear and tear. Now, since we're taking these files and we're sticking however many of them into that 1 terabyte object, we also put a little additional parity in each of those 1 terabyte chunks. Now, that allows us to have edge damage from one end of the tape to the other. Tape is actually serpentine, so there's actually no end to the tape. Most people don't know that.
Trying to figure out how it spools through the... Okay, carry on.
It's serpentine. That's all
Yeah.
you need to know. There is no actual beginning or end. But if you have edge damage continuously, we can actually still recover all the data because of that additional parity on the tape. You can have scratches. You can even damage the tape and tape it back together, and we can still read the data. That's pretty amazing. Now, let's say that tape is damaged beyond repair. It's broken. It gets, the library is damaged. There's a fire or whatever the case may be. We're doing a second erasure code across multiple tapes, potentially in multiple libraries, potentially across 3 sites. And as a result, you get that efficiency and that durability of spreading your data. You don't need multiple copies, and you're still more durable than if you had 3 copies of tape because of this wide erasure code. But the way we designed it, we actually retrieve individual files from one tape. You don't need to wait for 10, 20, 30 tapes to load to recover all that data. There's the potential that robots or tape drives or whatever will be offline or in use. And so we want end users to be able to retrieve files in as short as 5 minutes. So we're giving the customers an on-premise Glacier that has almost immediate access without egress charges, without choosing, do I need a bulk retrieve? Do I need an expedited retrieve? Or more importantly, thinking about what it's going to cost.
Interesting. Okay, so if I was to take all this and boil it down for a customer base, right? Because our audience out there is the resellers that are going to their customers saying, solving their data problems, solving their storage problems, where are they putting their files? First off, who's this for? Who needs this?
People with lots of data.
Studios,
Corporations, anybody who's got a lot of data. I mean, you're not going to be looking at ActiScale cold storage unless you have minimum 5 petabytes, but probably more than 10.
So every stadium in the country, every team in the country has got
The
at
leagues.
least, yeah.
I can specify that like Ultimate Fighting Championship has a very, very large ActiScale. But they also keep a tape copy as part of their StoreNext environment. So they're doing both. Now, they haven't moved into the erasure coded tape yet, but, probably change that.
It's time. Okay, so you've got the customer that's creating a lot of data. And then the highlight reel of this, if I was like to break this down, if you are the customer that is using both Object Store and Glacier, you're the perfect customer for this. Because you can front all of that or put all of that on premise or in your own premises at I would hope a significantly reduced long-term cost.
As the systems scale, the dollar per terabyte just drops more and more and more, especially over the length of time that you're going to be storing this cold data. People don't always want to store this data. They have to store this data. So they're looking for the lowest cost ways of doing it. And just like tape media lasts 10 to 30 years, well, our libraries, in some cases, have already lasted 10 to 20 years. The i6000 has been out for almost 20 years. We have customers who are still running them 19 years later. So that device gets paid off in its entirety. The media, once it's full, you're not buying new media. You're not paying support on that media. You're not paying a subscription on that media. So that the costs become controllable and the TCO gets better over time.
It's kind of interesting because we're going through this thing in the world right now, this strike that's happening. And if if you're watching this a year from now, back in 2023, the actors decided to take a break because they and the writers didn't feel like they were getting paid enough for what they were doing. And a lot of it's based on the streaming market. What's happening, right? Because we're no longer paying to watch each individual episode. We're paying a flat fee to watch as many things as we want, right? And so I kind of see this as, if I'm a studio with a lot of data, this to me would be very important because my cost per asset in terms of the value of that asset is sort of going down because I'm not getting paid each time it's used. I'm getting paid each time it's used 1,000 times, right? Or something different. So I would be looking for a less expensive way to store that media, to kind of hold on to it in that way. And I would assume this is sort of that.
Well, think of it as like the 100-year archive. Many of our customers who are looking at this have dozens of years or potentially 100 years of archive of media content. Think about how long ago the film camera was created. It's 100 years.
Yep.
And so you need to be able to hold on to that data. You need to be able to make certain it's protected and moved from media format to media format through the years. And you want to have a stable format that's not going to require that you swap it out every few years. quick anecdote about the space flights. When we went to the moon, they had a really custom camera that they used to capture those events. And 50 years later or whenever it was, they wanted to upres it to HD, pull it off the original film, but nobody had the actual reader anymore. Nobody thought, well, let's move it off to 35 millimeter film or something else.
Something that is, yeah.
So one of the amazing features and capabilities of Object Store is we'll just fail a tape or we'll fail a drive, and it will, by default, by the nature of the product, repair it. It's designed for failure. And so we can help customers not even have to worry about managing that media transition, because as part of the process of refreshing the hardware, we're just going to respread the objects and offline the old media.
Brilliant. All right, I'm getting told by the producers we got to wrap this conversation up.
So much fun.
I know. So now you're going to have another episode with us soon in the coming weeks, talking about Myriad, which is a complete departure from all of this. I'm excited to talk about that one. But in the meantime, if you're one of these people that has a lot of data and you're paying a lot of money to Glacier, I guess this would be, sort of call Quantum. It would be the message here.
Absolutely. Call Quantum will help your customers protect their data for longer, be more durable, and cost less. How can you beat that?
No, not at all. Jordan, thanks for being here.
Nick, always a pleasure.
All right. There's been another thrilling episode of Techsplanation. If you didn't learn something today, you weren't paying close enough attention, but make sure you watch the replay because you will find it on LinkedIn or at videos.jbanda.com. You can watch this episode over again and catch all the thrilling moments that we choked into this episode. Again, thanks for being here, and let's call this episode over and out.
Thanks, everybody.